So today we are going to start, that is, characteristics of first order reaction. Okay, characteristics of first order reaction. It is very important and also very easy to understand as well. Okay, so first we will start with the degree of dissociation in the first order reaction. Okay, so degree of dissociation. Degree of dissociation is denoted by alpha. So if you want to find out the degree of dissociation, so we will be using this sign of alpha. Okay. To understand this process, let's consider, for example, if we are having a reaction which is converting A into any product B. Okay. So at time 0 second, for example, when the reaction was not started, so the concentration of A that was considered, which is equal to, for example, small a. Similarly, when the reaction had completed or reached at a particular time t, so when the time was considered as a t second, okay, so we are taking as a concentration of A at time t, which is 80. Okay, this 80 will be remaining, for example, A minus x. So the like few formation has been taken place in the B part. That's why we are writing it as like A minus x. Okay, so how much the part has dissociated or how much the part has converted here? So we can say the dissociated part or the change we can find here. So dissociated part will become equal to your A node, okay, minus AT. Here, that will be our difference. Now, based on the dissociation or degree of dissociation formula, since we know that degree of dissociation means alpha, here I am writing DOD. So this degree of dissociation is written as, that is, moles or number of moles dissociated divided by your number of moles dissociated divided by initial moles. That's a simple concept, initial moles. Now I'll make it bold. Okay, so based on the alpha value we will put our values there. So since we know the moles of dissociations are here, these are our dissociated moles. Okay, that is A node minus AT. So here we will put the value there, that is A node means concentration of A node minus concentration at time t, which is 80, divided by, here we will be writing initial mole we had, that is concentration was A node. So it will become our alpha, which is your degree of dissociation. So I hope up to here everybody has understood. Here, if you want that the alpha should be more in detail, so we can find out, for example, so this, the next part I am going to write, it is only for the advanced level. Okay. So in JEE advanced, the same question had been asked initially. So for example, since everybody knows about that the concentration of A at any time t is written as equal to concentration of initial, which is equal to E minus KT, e raised to the power minus KT. If you don't know from where the expression had come, okay, I can give you the more detail also based on the same expression. So please comment for the same section here. Okay. So since we know about this area, so directly we can put the value of A here, means AT value will be directly putting here. So just put the value and we will be having the value of alpha, which will become equal to A node, okay, minus, here we can write that is A node and e raised to the power minus KT divided by here A node. Okay, just take A node common from all the sides, so all the A node will be cancelled out. Directly I can write that is 1 minus e raised to the power k, and t will become your alpha, which is your degree of dissociation. Okay, so this is a formula for degree of dissociation for directly first order reaction. I hope you understood it well. Thank you.